Now we're going to look at chapter 6 for investments. We're going to talk about efficient diversification. Talk about some methods to do that, and talk about some calculations so we can see if our portfolios are properly diversified or not. So market/systematic non-diversifiable risk is a risk factor to common to the whole economy. So this is what we can't get rid of. Okay, the non-diversifiable risk is the risk that we are going to have just based on the fact that the economy goes up and down. There's too many variables, too many factors that have to do that make the economy go up and down and change. So that's a risk that we kind of just have to accept based on the fact that we're investing in the market. Whereas unique firm specified non-systematic diversifiable risk is a risk that can be eliminated through diversification. So from a graphic perspective, firm specific risk only would look like this, where a market risk basically pushes that up, pushes it higher, the market and unique risk, and then our diversifiable risk is the difference between our decisions and how that can change the amount of risk that we have based on balancing. Usually it's a balancing of a portfolio, generally speaking. So portfolio risk decreases as diversification increases. So you can see as I gain more and more stocks, the less I have deviation from what I think the returns are going to, or what the stock or bonds or whatever it is I'm investing in, the equities of some kind that I'm investing in, debt or equity, will flatten out and effectively make my change, my amount of the stocks swing and change less and less the more diversified I am. So covariance and correlation. Portfolio risk depends on covariance between the return of assets. So what they mean here is that if I've got multiple assets, multiple investments, if they are two investments that happen to go the same way on a regular basis, meaning they, when the economy does well, they do well. When the economy does poorly, they do poorly, and both of them do that, then I'm not gaining anything through diversification. Diversification is meant to have more of a covariance so that, say for example, if I have one risky stock that goes up when we're in a boom but goes down when we're in a recession, the best way to balance that is with one that goes down when we're in a boom and up when we're in a recession. That way I am protected either way, whether or not we're in a recession or a boom, or hopefully anything in between. How I figure this out mathematically, and this looks more complicated than it really is, my expected return, so E is expected, R we're talking about return, P is for the whole portfolio, is W1, which is the proportion of funds in security number one, times the expected return on security number one. So whatever my proportion of funds, so say 20%, 30%, 40%, whatever the portion is, times what my expected return is, whatever my expected return, say it's 10%, and multiply those two, and then I add the proportion of funds in security too. Now I can actually make this much larger if I have 10 funds, 20 funds, 30 funds, 50 funds. You can just keep going with this. This is just a 2 security portfolio example, but you could have more than just 2 securities involved, or you can do groups of securities. You can do this with a lot of different types of numbers. So the covariance between them and the correlation coefficient, here's where we're trying to narrow down just how much they change in the same direction and whether one mitigates the risk of the other one or not. So covariance here, we've got a balance of risk. Now RS is my return on stocks, and RB is my return on bonds. And then you can see the sum of all my different assets. And I've got my expected return on stocks, my return on bonds, is my interest minus my expected return on bonds. My return on stocks, and I subtract my expected return on stocks. So that would be my variance. And just think about each one of these individually is the variance specifically for a certain type of fund. So this is my risk on stocks, this is my risk on bonds, and then I'm looking to compare them to see whether they covary in the same direction, different directions, or whether they mitigate risk for the other or not. Correlation coefficient, effectively we're trying to look to narrow down what a coefficient is, a number that I can find to estimate if my stocks do this, my bonds are going to do that. Okay, so if let's say that my coefficient is 2, my bond coefficient is 2, positive 2, it would mean that every dollar that my stock goes up, my bond should go up by 2. And vice versa, generally speaking, every dollar that my stocks go down, my bonds would go down by 2. If those were their coefficients, and notice that they're somewhat correlated because they're going the same direction. If I were to have a negative coefficient instead, a negative correlation coefficient, that means that they head in opposite directions of one another, where when one goes up, the other goes down, and vice versa. So you can have a positive or a negative correlation coefficient. Okay, so here is the first of several spreadsheets we're going to go through in this chapter. These numbers are just numbers they've made up, and we talk about how we can find these numbers through historical records here in a few minutes. But for now, this is just the numbers they've put in there. And all they did, I'll show you this in spreadsheet form as well. All they did was take the probability of it happening. So they said, okay, we think there's a 5% probability that there will be a recession. If there's a recession, our stock fund we think will drop by 37%. So if I take my probability times my rate of return, that gives me this negative 1.9 here. Mild recession, we think there's a 25% chance that'll happen. And again, these numbers they made up based on current economic conditions. The rate of return we think is negative 11, and in a mild recession. So again, we're just multiplying this by this to get this negative 2.8. And then we have normal growth. We think it's a 40% likelihood, and then our boom is a 30% likelihood, and so on. Over here, our bond fund. One thing you notice is that I didn't change the likelihood, and you don't want to. You want the probabilities to stay the same if you're looking at either multiple stocks or multiple bonds. Now, you'd want stock funds to be categorized, say, in all, say, industries or even specific stocks, one specific stock. Bonds, you probably want to categorize in risk factors or even AA, single A, the company's credit scores to see what the risk of default on those bonds. So once we multiply all those out, we expected our mean return of 10 for the stocks and 5 for the bonds. So just looking at this, if you're just looking at the one sum number, you would say, well, I just want to completely invest in stocks because at all levels I'm gaining more. But if you compare the two, you'll notice that if I think there's a mild recession, or I think I'm going to be in this area here, it might be a good idea to buy some bonds to protect me from this mild recession range. So if there's a mild recession, I'm expecting my stocks to go down by 2.8%. If I'm expecting a mild recession of my bonds, I'm expecting it to go up by 3.8, which means if I own both, depending on obviously what weight of each I chose to do, which we'll talk about in a second, this is where the weighted part comes in. So if I weight were exactly half and half, and I own half stocks and half bonds, according to these numbers in my mild recession, I would end up gaining 1%. Even though my stocks go down by 2.8, my bonds would equally go up by 3.8, and therefore my overall portfolio would go up by a total of 1 point. Then we can also take into account a variance on returns. So if there's a potential variance, or if we think that there could be a difference between what I think is going to happen in these and what has happened in the past, or look historically and see what's happened in the past, then we can do that as well. Similarly, I have this spreadsheet pulled up, 6.2, where again, these numbers are numbers that they just put in. Okay, these are all numbers they just put in. And then our standard deviation is the square of the expected deviation from return. I did that for all these. I square the deviation from expected return. Yeah, so I squared all those. And then for column B, for this column F, I take column B, which is the probability, times the standard deviation to figure out what my variance sum is. And when I square root that, that gives me my standard deviation. So the standard deviation in this case of 8, and the standard deviation over for bonds of 8.27. What does that mean? That generally means the stocks are riskier. It means that when things are going well, I'm going to gain more if I'm using stocks, but I'm not going to gain as much if things are going well in bonds. However, if things are not going well, I'm going to lose more in stocks than what I lose in bonds. So this one would be more secure. Bonds would be more secure and less risk. Stock would be more risk, but also a higher growth opportunity. Okay, 6.3. So spreadsheet 6.3 is the performance of a portfolio invested in the stock and bond funds. So if we did have an investment in the stock and bonds, we have our probability. The portfolio is invested 60-40 in this case. So we have probability of rate of return, negative 20.2 for a severe recession, column B times column C. So we're taking the probability times the return to get my how much of a return, or how likely it is. This is weighted by probability, so the likelihood of a return of a negative 20.2 rate of return. So this is my probability times my rate of return. Expected deviation from return, that's my expected return overall when I sum all these. This number here should be the sum of these four numbers, 7. The difference between my rate of return and my expected return. So that's in my formula, that's going to look like an ER, my expected return, minus my ROR, my rate of return. And this would be the deviation between the two. And then we just continue doing that. So we would continue to take the rate of return minus the overall expected rate of return to find that my overall, here I have my expected return, I have my squared deviation, just like I did on the prior one. And then I am going to take my column B, which is a 0.5 probability, times my column F, which is my standard deviation. And I'm going to find my variance, and then I'm going to square root that variance number to find what my standard deviation is. In this case, that's 6.65. All right, expected or return covariance. So now we're looking at how they vary with one another, okay, with stocks versus bonds. So we have, again, these are the filled in numbers that we have. We multiply my stock fund times my bond fund to get my product deviation. And then I take my column B, which is my probability times my product deviation, to find what my covariance is. Correlation coefficient is my covariance divided by my standard deviation in stocks times my standard deviation in bonds. So yeah, so I take my B times E, and then I would want to take my covariance, so that's negative 74.8, times my standard deviation in stocks, which I found on the prior one, I believe. If I remember right. Where's my standard deviation on stocks? There it is. My standard deviation on stocks, which is just 18.63, and my standard deviation on bonds, which is 8.27. So I would take my covariance, negative 74.8, divided by my standard deviation on stocks I just found, times my standard deviation on bonds to find this number, negative 0.49. Okay, now what methods can we use to find these numbers? So a lot of these were just plugged in and they just gave us, estimates based on their own scenarios. But we can also use historical data to figure out what this, the potential for variance and covariance. So variability and covariability slowly change over time, but we can use historical data to at least somewhat predict, not completely predict, obviously, but somewhat predict directionality, especially when it comes to returns, especially with regard to the economy. We can use realized returns to estimate. We cannot estimate the averages precisely. There's too many, and we can focus for risk on deviations from returns for the average value. So they come here. Actually, I'm going to stop the video here, continue with this asset allocation on too risky assets in the next video.